You can hear me?
Yeah, that's great.
We good in the back then?
And we see your screen doing what it does.
Yep.
Cool. All right,
I need to
good.
talk to them about a faster
All right,
process.
well, that was smooth. Let's go.
All right, here we go. Hi, everybody. Jason Ellis. I am the MMS consultant for the U.S. East at Leica Geosystems. Happy to be here today. Thanks for the opportunity to present what we consider the future of mobile mapping. Everybody is here to learn the latest and greatest, so it's good to see everybody engaged. Classes sound like they're going great. We appreciate this opportunity to share with you what is the latest and greatest offerings from Leica. But before we do that, just take a second to talk about the reality of the present. So the US is ranked 13th in the world in terms of infrastructure quality, and we have over 45,000 bridges, and 20% of our roads are in poor condition. There's tons of air, rail, and port systems that need to be updated, lots of utility and environmental projects that need dire attention. And mobile has helped answer and streamline a lot of these problems. But there's a lot of complexity built into the current systems. And oftentimes, as everybody here has indicated to me this week, and I've heard others talking, staffing is an issue. It's hard to find qualified people who have the background to operate and produce reliable results from mobile mapping systems. This is our solution. So the future is TRK, and the Leica Pegasus TRK is designed to allow new adopters and experts to access the most advanced technology and be effective in their roles. And we do this by eliminating existing entry barriers, so trying to minimize the complexity that we've all been working with over the years. We do this by focusing on autonomy, intelligence, and simplicity. In terms of autonomy, I'm talking about autonomous data collection, where the sensor knows where it's at and logs the data as needed based on mission plans. Autonomous accuracy estimation, so that when you're in the field collecting data, you're getting real-time feedback visually on the quality of your trajectory. Autonomous processing in the field, so that when you're done with your collection, your trajectory is processed and the data is attached to it, the LiDAR data, the imagery, you're ready to go to production. And autonomous calibration of all the peripherals that are attached to it. So cameras, DMIs, any external sensors automatically calibrated to the system without the need of laying down targets and doing manual calibrations in the office. And this is done by incorporating a new chipset that drives all the intelligence in the system. We're providing real-time blurring, smart power management in terms of the battery interacting with the system and the operator to alert us when there's an issue, and SmartFusion camera technology that combines our spherical images along with our front and side binocular cameras that you'll see here in just a minute. The whole system is designed for one person to install and operate in the field. It provides guided workflows to the workers in the field, so an operator is getting turn-by-turn navigation from the system based on the mission plan that was provided. And if there's an issue, we are also providing in-field live support where we can log directly into the system, and survey managers at your organizations can also access these systems to manage the plans and manage the execution of the data collection. So this is the TRK 700. Just gives you a rendering of what these systems look like. This is a TRK 700 with the dual head time-of-flight scanners on it, and all of the side binocular cameras installed as well. And on the system loadout, we're talking about two offerings, the TRK 500 and the TRK 700. The systems are identical with the exception of the scan rate. So the 500 has a single time-of-flight scanner at 500,000 points per second, and the 700 has a dual time-of-flight scanner configuration with 1 million points per second. The other difference between the two is the weight. The TRK 500 comes in at just under 40 pounds, and the 700 just under 50 pounds. These are hybrid module mobile mapping solutions, and I'll get into that a little bit more here in the next couple slides. But we also feature 360-degree SmartFusion cameras. And so basically what we're talking about is integrating multiple binocular cameras to maximize megapixel offerings through these systems. It's IP67 rated, which means we are completely impervious to all moisture and dust, solid particulates. You can actually submerge these units in up to 10 meters of water for 30 minutes. I wouldn't recommend that. We don't want to test airbags on our cars either, so they're all military spec'd on all the connections, so a very robust connection for all the peripherals. And our hybrid module solution is going to offer the highest absolute accuracy on your trajectories that you'll be able to achieve. We've also included the locate theft deterrence and location system. So basically what this allows you to do is to track where the unit is in real time, and if necessary, log into it and disable it. Now, we've managed to reduce the weight of these systems by removing some of the processing capabilities inside of the unit and putting it into a new controller unit where we've placed a dedicated AI chipset. So this controller unit allows you to collect up to 8 or nearly 8 terabytes on removable solid states. The controller unit is LTE, Wi-Fi, and LAN accessible. It allows for in-field processing and a whole range of other intelligent features that you'll see here in just a moment. It also has a 5.5-inch LCD touchscreen on it, so you can either control it remotely from a tablet or you can interact with the controller unit directly in the vehicle. We've reimagined the battery configurations from our legacy systems as well. So the battery unit offers a safe transportation mode where you just simply turn a switch and it disables all of the lithium-ion batteries and isolates them so that we can now meet all the air freight standards that are required for dealing with hazardous materials. It's expandable up to 3 batteries, so we can use 3 batteries in tandem, and the system will intelligently switch from one battery bank to another as needed. On one battery bank, you get up to 7 hours of collection, and it takes about 5 hours to recharge that unit. So just another look here. This is the Pegasus TRK 500. And one of the things that's interesting to me about the control unit that works with this is the idea of the control unit managing the calibration, but also managing the exposure and managing the white balance on the imagery all in real time based on the data in the images themselves, based on the histograms of the imagery itself. So having to manage image quality in the field is now a thing of the past. So when I talk about a hybrid unit, what we're getting at here is GNSS plus 400 hertz IMU plus a real-time kinematic connection to Leica SmartNet or another VRS system, coupled with the 2 dedicated SLAM sensors that you see on the front and the back of the unit. All of these sensors working together are going to yield the best possible accuracy on your trajectory. And it's also going to facilitate real-time it's not post-processing, right? It's real-time processing of your trajectory. Something else that I really like about having these dedicated SLAM sensors that improves our position in the field, they're intended for navigation as a primary function. But we log all that data as well. So you have, in addition to your workhorse scanners, you've got a forward-facing and a rear-facing LiDAR. It's like my mic. Oh, there we go. That you can use for whatever purpose. And this just gives you an example of how the SLAM corrections improve the trajectory. It's kind of hard to see with the lighting here, but on the left, we've got 40 meters of separation between multiple tracks inside of a parking garage where we had complete GNSS outage. That's the raw data on the left. And then over here on the right, when we apply the SLAM updates from those sensors, you can see that all the trajectory passes have come together very neatly. So let's talk about the cameras a little bit here. Again, these are fully integrated binocular cameras. So each unit has 2 lenses on it working together, and they each provide 24 megapixels of resolution. And the thing that's really great about these, for anybody who's got experience calibrating external cameras to a mobile system, that can generally be a headache. It takes time. It's a speed bump in the workflow. But what we're doing here is we're using the photogrammetry off of these binocular cameras and some of the developments that we came up with our Viz system off of the RTC 360. Maybe some of you were here last year and saw me present a little bit on that. But we're utilizing that technology to automate calibrations as well. So these cameras are plug and play and drive, and there's no human interaction as far as calibrating them. Here's just a shot of the front and rear pavement cameras on the 500. And here's the 700 with all 4 cameras installed. And on the tail end of this, there's a little, which shows you how it's flipped into the vertical position. So you could have 2 orientations. You could have a horizontal orientation for the cameras for building numbers, sign inventory type applications, but you can also flip them vertically for full arch, high-res imagery for overhead utilities and things of that nature. Just another example of what I was talking about. Quick illustration here that shows you how easy it is to flip these cameras. And again, the controller unit manages all this for you outside of, the physical manipulation of flipping it. Ultimately, what we're getting at here is a combined image resolution with all cameras of up to 120 megapixels per camera event. This is pretty good. All of these side cameras combined with the spherical camera gives us something that we could expect off of a 156 megapixel spherical camera. This is what I was talking about when I had mentioned Viz earlier, our Viz system on our RTC 360. We're using the imagery to track geometry points in real time in the scene. And then those geometry points can be applied directly to the real-time point cloud. This is what's providing our calibration. So we also teamed with Thule to develop a new carrier mount for the Pegasus. And Thule's been in the roof rack game for a long time, and we're a great collaborating partner. And we're really excited about the solution that makes using the equipment, physically using the equipment in the field easier and safer. I'm sure insurance companies will appreciate this as well. But we're basically reducing the lift requirements by 2 feet. So the way that it works is you set the carrier unit on top of the vehicle, and then on the underside of it, there's these lobster claw style clasps. And you tighten down on the thumb screws, and when they reach the correct torque, they spin freely with a little clicking noise so that you can't strip out the components. It's very secure on any third-party carrier rack that you have on your vehicle. Here's an example of what that would look like. Now in this rendering, they have the cameras applied. It's optional. You could put the cameras on afterwards to reduce the weight a little bit. But this is a 38, 39 pound lift from the ground, single handle, pick it up to about chest height, snap it into the cradle, and then your hands off. Once your hands off, there's a pneumatic arm that'll raise it into position. You slide it back and then lock it into a collection position. It's very simple. Now, I talked about the control unit before, and this is really the brains of the operation. This is where the field interface lives. This is what's prompting the driver on where they need to turn next, and it's what's prompting the autonomy in the collection itself. So it's equipped with LTE and Wi-Fi. So it's great in that a survey manager can access the unit in the field at any time. So if you want to log in and you want to set up a new collection plan for your field operator, it's very easy for you to do that. And the field operator in the field and the office manager back at home base are going to have the same experience. I talked about the battery unit. So the battery unit working in conjunction with the controller unit, they're intelligent in their collaboration as far as power management goes. So when you create a mission plan on the field software, not only is it going to determine the best routes to drive, but it's also going to tell you what the storage requirements are for that collection. It's going to tell you what the battery requirements are for that collection. If during the collection the battery unit is drawn down below what's acceptable for that collection, the system's going to step in and alert the operator that, hey, you've only got 5 minutes left for this collection. It's going to store all the data, it's going to save it, and then anything that wasn't collected during that collection is actually going to be transferred to a new mission plan, a remainder mission plan, if you will, that the operator can pursue after they've got ample power to finish the project. So I think that's fantastic. In addition to the battery being disabled for shipping, we also integrated a new security lock that stops that from being changed. So we can't have any accidental power off during a collection or an accidental power on during shipment. It also has an LCD screen that gives you a battery indicator as well. So just a few images here on different configurations. On the left, you have the controller unit and the battery pack. Then you have 2 batteries, and then we have up to 3 batteries working together, which would give you nearly 24 hours of collection time. This is the most exciting part: foldable anti-slip mats. Thank you. No. Yeah, anybody who's done mobile, if you're not using a ratchet strap or something, things sliding around, it's kind of nice that they did this as well. It makes it nice and clean. So this is, well, it's kind of hard to see, but this is a rendering of a very simple implementation. So like I mentioned, all of the accessories are intelligently calibrated to the system. That includes a mechanical and an optical DMI, a second GNSS antenna for marine and rail collections. All the peripherals are managed by the system. You can even see, yes, you can see on the GNSS antenna, we've included a target here. This allows us to use the photogrammetry and the LiDAR to automatically calibrate the position of that second GNSS antenna. So it's all hands off, minus the installation, of course. So the controller unit, back to the controller unit, the brains of the operation. This is where Pegasus Field lives. So this is our new interface for managing the Pegasus collections. And the whole idea behind this was to go from something that looked very sciencey to something that looks like, you know, any app that you have on your phone and or your tablet. Very intuitive, very easy to navigate, and new users should be able to adopt it very quickly. Stripping out a lot of the technical jargon and providing very obvious prompts, very obvious workflows, and it should lead to quick adoption from folks new to this practice. We're providing things like real-time trajectory quality indicators just based on simple color coding, and the limits of our LiDAR collection as well. So in real time, you can monitor the limits of your collection and the quality of your data. This shows a very quick example of how we can go in and plan or edit a plan. Different profiles for different collection types make these setups very easy. So you don't necessarily have to think about every individual setting. You can just select the right profile. Everything's pinch zoom with finger touch controls. Again, very simple to use, very intuitive. You can either select the area that you want to work in and let Pegasus Field decide the best driving route, or you can granularly go into your collection area, pick individual streets, and assign different parameters for them. Smith Street, I want 2 passes. I-75, I want 4 passes. When you make those parameter settings, either automatically or manually, during the collection in the field, the system is going to prompt the driver to make sure that all of those things have been accomplished. If you only drove Smith Street once, it's going to tell you, flip a UE down here, drive back, and it will log the data for you. It also walks us through the initialization process. So as we're sitting there doing our static observation, it's telling us, hey, you got 30 seconds left or 90 seconds left. And then when we start collecting, we can see the full range of the LiDAR as we're collecting. It's colorized in terms of trajectory quality, so it's very easy for us to understand how well we're doing in real time. And we can visualize this in 2D or 3D with generic map backgrounds or complete satellite overlay. We can do geotags in here, something of interest that we know the people in the office need to know about. We tap on the screen, make a note of it, and that's going to come in with the rest of the data. Very intuitive, very simple. This is an example of one of our support technicians in the US logging into a system overseas for support. When you're done with your collection, if you've gone the RTK route, or if you want to post-process, if you want to improve the relative accuracy of multiple passes, if you want to export different file formats, it's all done via Leica Cyclone Pegasus Office. So we're migrating the Pegasus family of products into the Cyclone family of products. And this is a good thing because it offers a very intuitive, very simple, straightforward way to work with your data that a lot of folks are already accustomed to. Fast processing times. I don't have I have a screenshot, but I didn't get it into my presentation, but I really like this feature, fast processing times. What does that mean? It means that when you're working with your data, you can visualize it and only process a very small subset of the overall data footprint. So this means that routines that we have to do regularly with our data, we don't have to wait an hour for them to complete. We just have to wait a couple minutes. We visualize the way everything looks. If we're satisfied with the solution that we have in terms of adjustment, improvements to our relative accuracy, any kind of transformations that you want to do, once we visualize it, we can then say, okay, we're good. Give us the high density output, and then let the computer do the work. But rather than having to wait on any kind of iteration of your data, you now get to work with a low density point cloud to do that. That's kind of hard to see, guys, I'm sorry. But we're working from left to right in Leica Cyclone Pegasus. So on the left, we've got a tab that lets you organize your projects. Let's say you've got a project that spans multiple days. Those days can all be related together. They can all be processed together. So it's very intuitive, very intelligent in the way that you can organize your data. We move over to processing. We've always prided our Pegasus workflows in the office. They've been pretty simple to work with. I call it the set it and forget it workflow on the legacy products. You're stepping through and configuring a minimum of 8 functions. At each stop, you have to go in and set a few parameters, and then after setting it up, it usually takes about 3 minutes, you let it go. Well, we've simplified that and boiled it down to like one checkbox. So it's very easy to work with a raw data set, if you like, and go from trajectory, processing, and analysis right to LiDAR. On the next tab, you can validate the quality of your data. If you want to do relative accuracy improvements, global accuracy improvements, you can do that. And then finally, on the last tab, finalize and deliver, is where we're looking at our survey reports, where we're looking at how well does our data, our final data set, match our ground control? What are those values? What's the RMS values? What's our min, mean, maximum separations? What's our 95% confidence interval? All of that is in the reporting from the Pegasus system. So it's also rated to 4 Gs of shock, so you can get squirrely with it. I don't know how wild I'd get, but that's the purpose of this slide here. So that's the future of mobile mapping, the way that Leica sees it. So I, again, really appreciate your time, really excited to share more with you. If you have questions, I'm happy to take them now or later at our display area. So thank you very much.
Thank you very much, Jason. Geez. So what have you guys been doing lately?
Yeah, we've been a little busy.
You've been a little busy.
Yeah.
It's a lot of new things. And one of the things that at Tuck, we appreciate our sponsors from Trimble and Leica and Regal. Just to come and share with you guys the latest in technology. I hope you found it as exciting as I have, listening to everyone here. And by all means, they're here. Talk to them, and see if what solves your problems, what meets your objectives the best, and it is our exciting times for all industries. So, I think at this time we go to lunch, and thank you for your
No
attention.
questions.
No questions. I'm sorry. Any questions?
We got about 5 minutes. So
we got 5 minutes. Okay. Any questions?
Yeah.
There's one in the back.
The one about the target, because you don't lay targets down.
Okay. The question was about the targets, not laying them down. So
Okay.
we get it recorded.
I don't recall saying that, but let me clarify. So when we're doing a collection in the field with the new systems, we have the option to use real-time kinematic solutions. So we'll get a real tight trajectory just based on that technology alone. But you can lay targets down and use the targets as a further global adjustment to the accuracy of your data. And that's done in post. So you bring the data back into the office, you feed the software a CSV file of your control points. The software then goes through your LiDAR, finds the targets that those points relate to, and it measures from the survey control point to the point that it found in the LiDAR data. It's calculating a delta XYZ. That's a trajectory adjustment at that point that we perpetuate along with the other trajectory navigation sensors. Does that answer your question, sir? Okay.
Yes. How much does it cost? There's the real question.
Thanks, everybody. It's competitively priced. So we understand that mobile consumers have an expectation of cost to benefit. And where the real bargain is the benefit. So we're competitively priced with these systems, but what you're gaining is, in my opinion, a massive leap forward in capability. How's that? Was that a political answer?
I was going to say, I'm going to leave it there. But, you know, there's options. Look, I mean, I always say, what's your market? What's the potential? What are you going to spend to meet that market requirements? You know, and if you say $200,000 or $300,000, but entire markets are left out to you, or it's taking you twice, 3, 5 times as much to prolong the process and things like that, a couple $100,000 goes away very quickly. So I mean, so that's kind of the evaluation you have to make for any system, really. So, you know, we'll leave it at that. I'm sure it ain't cheap, but whatever.
It's all relative to.
It's all relative. It's how much money you make. That's about profit at the end of the year, right? It's not about, you know, how much you spend. It's how much the return on your investment.
Right.
It's really the thing. So, you know, anyway, and anyways, other questions? Sorry.
All right. Thank you all.
All right. Thank you, guys.
Thank you.